Suppose an actuary wishes to predict the size W of a claim using a predicted T. W and T are independent and normally distributed with same mean and variance, 4 and 12 respectively. And we have to find the probability of absolute W minus T is less than 1. So we will let W minus T equal to another variable. Let's call it X so that it's easy to do the calculations. And since X will be the difference of two independent normal variables, so X will also be normal. And we are given that W and T have the same mean. So the mean of X will be mean of W minus mean of T. And since W and T have the same mean, so the difference of their means will be 0. So mean of X will be 0. And variance of X would be, so we can recall this formula that variance of a linear combination. So if X was AW plus BT, then the variance of X would be A square variance of W plus B square variance of T. And in this case, A is 1, A is the coefficient here, and B is -1. B is the coefficient of the other variable. So our formula is telling us that you square the coefficients. So A square is 1, and B square will also be 1 because the square of -1 is 1. And so this part will also be 1. So we end up having variance of X equals variance of W plus variance of T. And we're given that variance of W is 4, variance of T is 12. So 4 plus 12, 16 would be the variance of X. And the question was to find probability absolute of W minus T is less than 1. So we're calling W minus T as X. So we want probability absolute X is less than 1, which is the same as X between -1 and 1. So we need to change -1 and 1 into z-score. So z-score formula is X minus the mean over standard deviation. And for the -1, when X is -1, the z-score will be -1 minus the mean. And we calculated above that the mean of X is 0, variance was 16. So -1 minus 0 over square root 16. Standard X sigma is the standard deviation. So if variance is 16, then standard deviation will be square root of 16. So that's -0.25. Similarly, the z-score of 1 will be 1 minus the mean over the standard deviation will be 0.25. So probability X between -1 and 1 equals probability Z between -0.25 and less than 0.25. And that's the probability of Z less than 0.25 minus Z less than -0.25, because probability of Z between A and B is probability Z is less than B minus Z less than A. So our table of the exam doesn't have negative values. So probability Z is less than -0.25 is the same as Z greater than 0.25. And again, the table is cumulative. It goes in the less than direction. So we have to change this greater than into a less than. So Z greater than 0.25 is the complement of less than 0.25. So strictly speaking, this should be less than or equal to 0.25, but in continuous variables, you can be careless and you don't have to worry about whether the equality is included or not. So probability Z less than 0.25 minus this part is 1 minus less than 0.25. And when you distribute this negative, this is -1 and this becomes plus Z less than 0.25, so it gets added with this one. So you have two of these. This is Z less than 0.25, and then the -1 comes from here. And now if you look in the tables, you will find corresponding to 0.25, you will find a probability of 0.5987. And therefore, 2 times 0.5987 minus 1, and that's 0.1974. That's choice A.